Okay, so we're going to go over vertical stretches and compressions. So we're specifically talking about when the value of A is in front of sine x. Now, we have talked about y equals, and we've shown a sine, and we also will talk about one other one. We're going to use our C and our D values also. So we had plus D, which did vertical translations, minus C did horizontal translations, and we have another value of K, which will do horizontal. So A and D both do vertical movements, and K and C both do horizontal movements. So just keep those in mind. We're going to focus specifically on A. Now, when A is a value greater than 1, okay, it will stretch it. So we'll give you an example of something like that. Let's say we have y is equal to 2 sine x. As a trick, what we can do is take each of our major coordinates, okay, and what we do is we multiply the y values by a. So I write it as ay. And for your x, I'm just going to show it, though we don't have to do it for a values. We would divide our x values by k. So we're going to focus strictly on a. So what do I mean by that? Okay, well, here's a coordinate at 0 and 0, right? So we have our coordinate 0 and 0, and our a value here is 2. We're going to multiply the y of this coordinate by a. So in this case, 0 times 2, what's our new coordinate? Still 0, 0. So this point is the same. We have another coordinate at 90 and 1. We're going to multiply the y value by 2. What's our new coordinate? 90 and 2. So we go over to 90 and we plot 2. Our next coordinate is 180 and 0. What's our new coordinate going to be when we multiply it by 2? 180 and still 0. 0 times 2 is still 0. So if you're noticing, the 0 coordinates, or the coordinates along the equation of the axis, haven't moved from where they were. Our other ones are, though. We have 270 and negative 1. What's negative 1 times 2? Negative 2. So our new coordinate is 270 and negative 2. And 360 would be at 0. So a stretched sine wave where a is 2 has this effect. Okay? We have vertically stretched where it originally was. And we would continue that pattern all the way to the very end here. Okay. This was hard? Higher. Oh, I'll fix that. Thank you. Right, that is higher. There we go. So this is our vertically stretched sine wave. When our a value is 2, it vertically stretches it. We'll do another one. When a is between 1 and 0. Okay? So for instance, let's say we have y is equal to, I'm going to actually use 1/4 sine x. Now you can write this as a decimal value if you like, and we're going to do this graph in purple. Okay? Our a value is 1/4. So same idea. We could take those major coordinates, our 0, 0, 90 and 1, 180 and 0, and we're going to multiply the y value by 1/4. So this coordinate stays the same at our zeros. 90 becomes 90 and 1/4, or 0.25. 180 and 0 is the same. So just to give you a general idea, and then we'll tune it from there. Actually, let's do 1/3. Just because this happens to be broken into thirds, it'll make it much easier for us to write out. Okay, so say it was 1/3 instead. And they would give you these values. I'm not just pulling, or I am pulling these numbers out of nowhere. They would give you these values, okay? So it would be 1/3. So what does that mean for this? Well, we would still be at 0 and 0. 1/3 of 1 would happen to be here. 180 and 0, which means negative 1 times 1/3 would be negative 1/3, which would put the graph there and there. So if you notice, this is a compressed version. Okay? It's gone down from the original one. And you can continue that pattern also as you go through it. This is a compressed version of the original black sine wave. And the last thing we want to talk about, okay, I'll do it in green, this one, but what if a was a negative value? Equals a negative term. Well, if a is negative, let's say we have y is equal to negative 3 sine x. Okay. It's the very same idea. We'll do this one in green. I'm not going to write the coordinates out. We're going to try to just keep them from where we were. My origin, will that change? No. This point will be the same. When I multiply 1 times negative 3, what do we get? I get negative what? 3. So this coordinate is now at 90 and negative 3. So it's going the opposite direction that it previously was. Our zeros are still the same. This coordinate at negative 1, when I multiply it by 3, what will it become? Positive 3. Okay. So this is a very stretched sine wave, but it seems to be inverted from where it previously was. And we can continue that pattern also. So, our negative values will flip our wave on the x-axis. Okay, so when a is negative, it flips it on the x-axis. It almost starts to look like a DNA chain here.